Okay, let's look at number 11. Write a polynomial function with least degree and integral coefficients whose zeros include the following. So we have a x equals 3 is one place it crosses the x-axis. X equals 2 minus 1 is another place. So since they're given us a complex number, 2 minus I need to add the conjugate of it, x equals 2 plus I, just like we did for number 10. And so I have these two complex zeros, and I want to set them each equal to 0. So when I subtract the 2 minus I, I have x minus parentheses 2 minus I equals 0, and x minus parentheses 2 plus I equals 0. So I'm going to distribute that negative throughout both of those complex roots and regroup, so I have x minus 2 together. So you always want to regroup so that the I is outside the parentheses, and you have a plus I and a minus I. So my binomials are the same, so I can consider them one term. Okay, so when I multiply those two factors together, let me start that over. I got x minus 2 plus I times x minus 2 minus I. Okay, so remember your shortcut for multiplying conjugates. We're going to square the first term, which is x minus 2, square the last term, and subtract them. So when you square a binomial, you have to FOIL it to itself. X minus 2 times x minus 2. That will give me x squared minus 4x plus 4 minus, then I squared is actually negative 1, so this is going to be minus a negative 1, which is plus 1. We'll combine the like terms. So I wind up with x squared minus 4x plus 5. And now I'm ready to multiply it by this other root where x equals 3. If I set that equal to 0, then x minus 3 equals 0. X minus 3 is the last binomial. So I'm going to multiply by x minus 3. And we're just going to be very slow and methodical to do this so we don't mess up. X squared times x is x to the third. X squared times negative 3 is negative 3x squared, so I'm done with that first term. Negative 4x times x is negative 4x squared. Negative 4x times negative 3 is plus 12x, and I'm done with that middle term. 5 times x is 5x. 5 times negative 3 is negative 15. I'm done with that last term. So now I can combine my like terms, and I will have my polynomial back. And this is your polynomial. There are no i's. Now we're ready for the last part of our notes. We're going to look at number 7. And we will probably do another one tomorrow in class together so that everybody is understanding what we're doing. Okay, so the directions say use synthetic substitution to find all the zeros of the function. Find values of the function that are 0. Divide that into the function and then find the remaining zeros by factoring or using the quadratic formula. Okay, so here's my calculator. I'm going to use the calculator for this one to help me find a 0. Now, the degree is 3. So I know that the ends are going to go opposite directions. The leading coefficient is positive, so that means the right side's going to go up, the left side's going to go down. And I could have, at most, 2 turns. Okay, so first we're going to type in the polynomial for number 7. X to the third minus 4x squared plus 6x minus 4. Okay, so there's my graph. And it does a little squiggly, like maybe it's trying to do a couple of turns, but not quite getting there. So I think that that is going to be the extent of my graph. I know it crosses the x-axis at this one place, so let's find out where it crosses, what the value of x is. So we're going to go to the table, and I want to look for where y is 0. So this is where y is 0, x is 2. That's where it crosses the x-axis. Okay, so I found a root. X equals 2. That's one of my answers because that's where it crosses the x-axis. So I'm going to use that value to divide into my polynomial and see if I can get my other factors. I don't have to put any zeros in because none of my degrees are being skipped. Bring down my first term, that's 1. 1 times 2 is 2. Add those together, that's negative 2. Negative 2 times 2 is negative 4. Add those together, that's a positive 2. 2 times 2 is 4. Negative 4 plus 4 is 0. So that's what I should get, since 2 is a factor. I should get a remainder of 0. My depressed polynomial is x squared minus 2x plus 2. So I want to solve for my other x's, which, since it only crosses the x-axis one time, that means that the other values must be imaginary, right? And if you look at the sign changes, you do have one sign change right here, one sign change right here, and one sign change on the last one. So for positive zeros, I could have 3 or 1. In this case, I'm just going to have 1. So since those are probably going to be imaginary, I'm going to use the quadratic formula because I can't factor it. It's prime. Okay, so your A is 1, B is negative 2, and C is positive 2. So let's plug it into the quadratic formula. Negative B plus or minus the square root, B squared minus 4 times A times C, it's going to be 8, all over 2 times A. Okay, so that's 2 plus or minus the square root of negative 4 all over 2. 2 plus or minus 2i all over 2. And I can factor 2 out of everything inside, or in the numerator and the denominator. So that's going to simplify to 1 plus or minus I for my imaginary roots. So I have x equals 1 plus or minus I and x equals 2. And those are all my values for that polynomial. Okay, so let's go ahead and do number 8. F of x equals x to the third minus x squared plus 2x plus 4. Okay, the thing is, you were doing this in the last section, but they were giving you factors of the polynomial to divide with. This time you're having to find it yourself. So let's type it into the y equals screen. X to the third minus x squared plus 2x plus 4. Okay, and look at the graph. It does cross the x-axis one time. The leading coefficient is a positive 1, so the right side's going to go up. The degree is odd, so the left side's going to go down. So it looks like it's kind of the same case as we had last time. It's just going to cross one time. And here, y is 0 when x is negative 1, so that is 1, 0 on your graph. X is negative 1. Okay, so to get my other two roots, I'm going to divide by this negative 1 because I have to get my degree down to a squared term, or something I can factor. Right now I can't really factor this. If I try to group and factor, it's not going to work for me, so I need to get a 0 that I can divide with, and then it's going to be down to a quadratic, and then I can use the quadratic formula, to find my x. So 1 times negative 1 is negative 1, that's negative 2. Negative 2 times negative 1 is 2. Add those together. 4 times negative 1 is negative 4, so that's going to be 0. So my depressed polynomial is x squared minus 2x plus 4. which now it's down to where I can factor or use the quadratic formula. In this case, I think I'm going to use the quadratic formula because, again, I think this is prime. So my A is 1, B is negative 2, and C is 4. Okay, so x equals negative b plus or minus the square root of b squared minus 4 times a times c, that's going to be 16, all over 2 times a. So 4 minus 16 is negative 12. I have 2 plus or minus the square root of negative 12 all over 2, so I'm going to have 2 more imaginary roots again. And I can simplify that square root of 12 to 2i radical 3. And again, this numerator, I can take a 2 out all the way across, so that's going to simplify to 1 plus or minus I radical 3. So here are my 2 imaginary terms, and then I also have x equals negative 1. I found all 3 of my zeros, just like my degree says that I have 3. And those are your answers. We'll talk more about this tomorrow. I can do another example for you if you need me to. You can ask questions, and we'll work on the assignment in class. See you later.